All right. A big part of the chapters that we've gone through, they will talk about how you split up variable and fixed costs. And so you'll have whatever the costs are. You know, these are going down a list here, and you say, okay, some of these are variable, some of them are fixed, and they'll list them out. You know, this is what variable, these are what fixed, and at the bottom you can get a total of what each of them are. The problem with that is that you may have thousands of items. And not only may you have thousands of items, it may be difficult to know what's variable and what's fixed. There are things that are variable and there are things that are fixed that are, there are things that might be both. I always use the, you have electricity for a computer lab. The lights, if there's one person in the room, the lights will be on. So the lights are fixed because if there's one person in the room, the lights are on. If there's 50 people in the room, the lights are on. The computers, though, are variable. If there's one person in the room, they're only using one computer. If there's two people in the room, they're using two computers, and so on and so forth. So if you look at an electric bill and you try to classify it, it would be difficult because some costs are just they're hard to know whether they're variable or fixed. And it may be a little bit of both. So what sometimes is easier than trying to, find the variable, find the fixed, and have this be the total cost. Sometimes it's easier to start with the total cost and then break those two out. So you take the total cost and say, okay, we can use the total cost to figure out how much is variable. Oops. And how much is fixed. So you're going to take the total cost and then try to split it up between those two. And it does two things where usually this is much faster. You could literally be dealing with, well, I'll tell you, we had a maintenance shop at one of our production plants that had 240,000 parts. Some were variable, some were fixed. Who wants to go through 240,000 parts and figure out what nobody. And not only is it much quicker, but it's also more accurate usually. Because something that you might think is one might really be the other. Something you think is fixed might really be variable or vice versa. So if you do from the total cost, you can eliminate those. The two methods we're going to use are the high-low method and linear regression. Okay, and these two, we take the total cost and then try to split them up. All right. I need to get my handout up. Okay, let me share here. All right. To be honest with you guys, I've never done this handout like this. So we'll see how it works out. Hopefully it'll work out. So here we have some information. We have, they're making toasters. And we have some total costs here. And these total costs have both variable and fixed costs. So what we're going to try to do is use these total costs to come up with how much of it is variable and how much of it is fixed. Okay. So let's go ahead and get started. Now, the high-low method, I'm trying to think if I should do this. I think they do it right here. Oops. The high-low method says, okay, you just take the units and the total cost for the highest and the lowest. So looking at our toasters produced, which was the highest?
Week 32.
Yep. Week 32, we had 13 units. And the cost was 115,000. No, 115,000. I added some numbers there. And the low was 6. Let's make that one green. Okay, so what's that there for? I think it's the leftover from one of the other ones. Okay, so we have units produced. We have 13, and total cost is 115, and 6 were cruised to the low. Now, the difference in total cost, is that difference due to variable or fixed costs? So the total cost has both variable and fixed. If that cost change, if total cost changes, is the change due to variable or fixed cost?
Can you just repeat the question?
Yeah. The total cost changed, right, between these two? They're different. So if these costs are different, is the change between them, is it due to variable cost or is it due to fixed cost? Which cost would probably be the one that changed?
Variable.
Variable. So any change, for instance, the rent wasn't good. The rent week 31 is the same as rent week 32. All right. So if anything changed in here, it must be due to variable. So we can use that down here. So what we're going to do is take the difference. So we're going to subtract these. We'll put a negative here. Negative there. So the difference between the two, 13 minus 6 is 7. And 115 minus 80 is 35. Dollars in front of those. Okay. So we now have this difference. Delete this row. the difference is 7 units, and it changed the total cost by $35, and we know that that change is due to variable costs. Right, this must be a variable. Okay, so the question is, what is the variable cost per unit? We made
$5.
Yes. Yep. So the change in total cost was $35. Ah. Yeah, I know how to do this. It doesn't seem like I know how to do this, but I do. It'll be so oops. I don't know how to type, but so the change in total cost divided by the change in units. So total cost of change is $35. And the units change was 7. So that will equal 35 divided by 7 is $5. So this will be the variable cost. I know. Okay, so the variable cost per unit is $5. So we're halfway there. The variable cost per unit is $5. Now we got to find the fixed cost. And for the fixed cost, you can take either the high or the low, and you can use that to determine your how much of this is variable, how much of it is fixed. So let's take which one? We'll take I guess we can take the low one first. I'll put it up here. Okay, so this $80, some of it is variable and some of it's fixed, right? You know, it has both of them in there. So the question is, how much is variable? Well, the units we had were 6. I tell you, let me start with the price first. The price each was $5. Multiplied by 6 units equals 30. $30. So this is the total variable cost. Okay, well, if we take the total cost, it has both variable and fixed. Subtract out the variable cost of 30. Oh, come on, that's plenty of room. Okay, that equals what? 50? So that must be the fixed cost. Let me make this one, no, let's make this one different. Oh, I know what to do. Come over here, let's say. So the fixed cost would be $50 total. Now in this one, you can check your answer by doing the same thing for a high. These would change, obviously. Instead of 6, this would be what, 13? Let me do something here. So this would be 13 units. So 5 times 13 is 65, I think. Hey. The total fixed cost is 115 minus the variable. Give you another 50. So these two are exactly the same, and this is what you'd expect, right? If they're fixed, you know, for instance, if this was your rent, if your rent was $50, and someone says, "What's your rent?" Well, it's $50. I mean, it's not going to change. So you can actually check your answer on these. Now, you know, the question is, do you have to do it twice? No, you don't have to do it twice, but if you want to, you can, and you can, you know, check on your answer. Let me zoom out a little bit. So notice what we did. We didn't go through each item and see what are they making? Toasters, how much of the steel, how much was the labor, how much was the rent, how much was all that? We didn't do any of that. We simply took the high and the low. Oops. This is the high. This one was the low. And we use those for to come up with our variable and fixed cost. Any questions?
Question.
Yeah.
So, like, for like a real life scenario, like, what if the variable costs were like $5, like 60 point or 0.666666, like something like that? Would you round that, or would you like keep it like as it is, or?
It depends on what you're doing. You can certainly round it to like say the nearest. In as a practical matter, maybe rounding it to the nearest cent. Because I mean, $5.11. You might not think the 11 cents is much, but if you're selling, 6 million of something, 11 cents is a lot. So I would say round it to the nearest cents. I can tell you something like an extreme case. When I was at U.S. Steel, we rounded the price for each pound down to 13 decimal points. And you say, why'd you do that? Well, because we'd sell these things in chunks of 80,000 pounds. So, 80,000 times something can add up. It is there's a practical matter of what it could come to. And if you do that, so if you round on one of these, just know that your fixed costs might come up a little bit different. They should still be close, but it might come up to be a little bit different. So I mean, it won't be, it won't be up by thousands of dollars, but it might not be exactly it. So maybe this one would be 49 and this one would be 51 or something like that, if we had to round it. So again, this is a it's kind of an estimate, is basically what it is. And because of the rounding, the fixed cost might be a little bit off. But if you round off to the nearest cents, you're fine. For most things, anyways.
Okay, thank you.
You're welcome. For the high-low method, the high-low method, you guys shouldn't have a problem with it, but if you do it in class, a lot of times the high-low method is more missed than the regression method. But the biggest error people make in this one of the biggest errors, is they don't pick the highest and the lowest. So they pick the highest and lowest. And by the way, I don't think it comes up in this class. But when you talk about the high and the low, you're looking at the production, not necessarily the total cost. The total cost the high-low might be different than the production. So whatever the production high-low is, usually is what you use. Okay, let's do the same thing for 2. I think I'll shut up for a minute and see if you guys can figure it out.
What's the total cost for April? I can't see. There's like a gray box in the way.
For April?
Oh, it went away.
Yeah. You have a copy of it though, right? Did you get a copy of it or no? The handout?
Yeah, I got a copy. I'm sorry. It's been a long day.
Well, no, I was worried because I did get a message that some people didn't get it, so I was worried about that. I don't like light blue. So variable cost. Okay. Oh, I didn't put my my thingies in here. Put the these things. Those two are the same. Okay, so I did something wrong
Can I see the bottom part where you have, yeah, that's that equation where it says high low difference? That's the part I need.
here. Okay, this part.
Yes, where it says high low difference and the change.
Yeah. Okay, so so that one, right? Do you see it or no?
Yes.
Okay. Yeah, and again, you know, the reason the thing that we're doing here is we're just taking the highest and the lowest, and you're kind of working out an estimate of what the variable and fixed costs are. Um,
Oh, Professor Taylor, could you switch your screen so we could see what you're writing?
No, actually, I realize I'm writing the wrong thing. Yeah, I will switch my screen. I'll do it now. I just use a pencil. I realize it. Here's what it's kind of doing here. We have all these different data points, you know, that are whatever, and we're just taking the highest and the lowest, and we're kind of making an estimate of what it is. And you'll notice that, you know, a lot of times, and this is true, will be true of the other method we use also, that many of the things, if not virtually all of the things, will not necessarily be on that line, but it's going to be our estimate that, you know, this would be a fixed part would be down here. I should have made this a little bit bigger, but the fixed part on that last one was what, 20, no, 34. So like if that was your rent or whatever, this would be 34. And then each unit that you added would add $4 to, you know, the total cost. So as you go up here, plus, you know, so you're kind of just making an estimate of, you know, this kind of cost function. And so the fixed cost, you know, the 34 would be kind of like where we start at. And then as you add units, the total cost will go up. So that's kind of what we're doing. And we're going to find, though, that there are some problems with this method. It's a good method. You know, high-low is good for doing things fast. It's fast. Because you just have to find the highest and the lowest, and you can go. You know, you can do it. There are some problems with it, though, and that a few things. First of all, a lot of times the highest and the lowest are not the best ones to use. You know, sometimes the lowest ones are kind of crazy, and the highest ones are kind of crazy. You think about like a retail store that sells. There are some stores that sell half their year sales come in December. So, you know, their December is going to look crazy, and their, you know, February is going to look crazy, and you know, so a lot of times the highest and the lowest are not the best ones to use. But again, it's for what it is. If you can just get the highest and the lowest numbers, you can get an estimate of what it is. And that's kind of what we're doing here. You know, just getting a kind of an estimate. And here's how you use it. So it's down here, calculate the total if 5 toasters are produced. Okay, well, the total cost would be both variable and fixed. And by the way, one more thing, let me talk about this here real quick. I promise I'll show you. So this is variable plus fixed is this 50. You know, that's variable plus fixed. And so when you come over here, we're minusing, we're really just minusing is the variable. So if you have variable and fixed are 50, and the variable is 16, you know, then this will be the fixed over here. The fixed is 34. So it really is just, you know, you think about it, and the same thing down here. This is really variable plus fixed. Is whatever that is, 74. And if you subtract out the variable, then you'll end up with just the fixed. I should change that variable one, but yeah, I'll take that out. Oops, I didn't do that. So variable plus fixed minus the variable gives you the fixed. So that's really all we're doing is this. taking the total as both of them and subtracting. Now at the very bottom it says, let's do it the other way around. Let's take the variable plus the fixed and get the total cost. So down here it says, okay, what if you made, the cost of 5 toasters are produced. Okay, well, what would the variable cost be? I should say that, what would the total variable cost be? And what would the fixed cost be? And this will be the total cost. Yeah, I guess there. Okay. So if we made 5 toasters, or 5 units, the variable cost per unit is how much?
$4.
$4.
Yep. So I'll say times 4. Okay, don't do that. No, I thought I was doing that. It's automatically capitalizing. I'm trying to be helpful. I hate things that are helpful. Like that. That wasn't helpful. Okay, yeah, so 5 units and equal. What equal? So 5 units, what is that, 20? So the total variable cost would be 20. Each unit costs $4. The total fixed cost was 34. So the total cost would be those two together. $54. Question on that thing? So this is just beginning the the total cost. So this is kind of one of the ways you might use it to figure out. And you'll notice that we don't have any up here that show 5 we don't show any that show 5 toasters that were produced. But you can kind of come up with an estimate of what you think it might be based on these, the variable and the fixed cost. So you say, okay, if we're gonna make 5 of them, it's gonna cost $54. That'd be an estimate. Question on that? Okay, let's go ahead and take a break, and we'll come back and what time is it? 6:56. Oh, I don't know. Let's make it a strange one. It'll be 7:03. And we will start in on the regression one. We're gonna go to page 4. We'll start on page 4. We're gonna skip page 3. Oops. But we'll do it next week. Skip page 3. I think you guys probably have this down. So we're gonna go. When we come back, we'll start on page 4. sorry, I was talking to myself. Okay, so we're going to do linear regression to come up with a variable and fixed cost for a couple reasons. First of all, it's more accurate. It's a more accurate way of figuring out the variable and fixed cost because it takes into account all of the data points instead of just taking the highest and the lowest and say, okay, you know, it says, okay, we're going to take all the data points and we're going to look for the one that fits the best. So whichever one fits the best is what we're going to use for our estimate. It's sort of like the best estimate you can come up with is using a linear regression. So that's what we're going to do. Now, a couple things about this. This is kind of the way, if you guys had your, if you had statistics class, you guys probably did something similar to this in there. But one of the things, the reason why I like to do it this way is also to get used to using the symbols for, you know, the equation has symbols in it. And they look kind of daunting, but they're really not. And it's one of those things that in math, people who are more comfortable using symbols, especially if they came from a language that uses symbols, it's usually a little bit easier. But for the most part, a lot of the stuff that we do in it is not that difficult. If you just think about the symbols as what they are, what they're really just saying, it's sort of like someone's shorthand, basically. So anyway, we're going to do the. Let me change cameras first of all, and then share screen. So what we're going to do here is, now we're just going to do it with 3 months. We could do it with 10 or whatever, but it just makes it a little more complicated. So what we're going to do is have our, we have our data, and we're going to use this function down here to figure out our variable cost, and then the one down here to figure out our fixed cost. So what we're going to do is kind of try to figure out these two. Now, there's two variables, x and y. And one of the things that we have to figure out is which ones are x, which ones are y's. For business, it's usually not too bad because the total cost will always be the y's. Everything else will be the x's. So this will be a x, and that'll be the y. So the total costs are always the y's because this is what we're trying to explain. We're trying to explain the total cost. So the total costs are always what we're trying to explain. That'll always be the y's. If those of you who've had statistics before, one of the problems is figuring out what you're actually trying to explain. And this, for us, it's kind of nice in that it's always the same for us. It's going to be just the total cost. Okay, so what we're going to do is for each one of these symbols down here, we are going to see how we actually work these out using this up here with these x and the y's. So I'm going to, okay. Let me zoom in a little bit. All right, so when you see the squiggly here, it's actually a sigma, but when you see that in front of the two variables here, what does that mean?
Does it mean the sum of?
Yep. Yeah, you're going to sum them. Now, when variables are right next to each other, what does that mean?
You multiply them?
Multiply. And which do you do first? Do you add them first or do you multiply first?
I believe you multiply first.
Yep, you multiply first. So what we're going to do is we're going to come over here, and we're going to multiply. Get my keyboard out. We're going to multiply x times y. So here's our x, 5. Here's our y, 55. So 5 times 55 is some number that I'm going to calculate right now. Turn the calculator on. That's a tip, people. Write that down. So 5 times 55 equals 275. Okay, so all I did is multiply these two. The 5, the x times the y. So we're going to multiply all these out. So the next one would be 6 times 59. For 8 times 72. 576. Oops, that's not right. Try that again. Okay, how come you're not all lined up? Okay. All right, so 5 times 55 is that. 6 times that is that. 8 times 72 equals that. And so then we're going to add them all up. We get so that is our, I'm going over here, I'm going to copy this. You don't have to do this, by the way. So that is going to be our x times y. I think I'll put that in here. So this will be the first our first term, you know, this one will be the 1205 minus. Okay, now we got to jump to the second term here, and this one's a little more complex, a little more stuff going on. All right, so let's see. The sigma here, the squiggle just means sum, and the parentheses says x, so we're just going to add up the x's. All right, so this is just adding up the x's. So here's a squiggle, so in the parentheses there we'll have that. So let me see it. Yeah. Okay, so I'm going to take 5 plus 6 plus 8. I should be able to do that in my head, but I am an incredibly lazy person. So I'll use my calculator. Okay, so that is 19. Compounding my laziness, I'm going to copy this over here so I don't have to figure out how to get it. Okay, so this will be minus 19. We're going to the second one here. Sum of y. So we're going to sum up all these y's. Okay, so 55 plus 59 plus 72 equals some number. $186. So that's the sum of y. Those of you that have had statistics, does anyone want to jump in and what the n would be? I'll give you a hint. The n has to do with averaging. So if you're going to average something, if you're going to average, total produced, what would you divide by?
So be the average? No.
Well, how would you get it? If you wanted to get the average, say, of 19, how would you get it?
Divide by 3.
Yep. So n is just the number of months here. So this will just be n. This will be n equals 3. If we had 10 months, it would be n equals 10, and so on and so forth. So the n is just a number, however many you have, January, February. So there's 3 months, n equals. That's supposed to be a small n. Quit correcting me. I know I make lots of mistakes, but this time I'm not. So the n would be a 3. Oops. And then we put brackets around it, and that would be the first part. So this is that first, first one up here. That's what that is. Okay, now do I want to come over here and do this? Maybe I'll do it over here. I don't know. It might kick me off the page if I do it over there. Yeah, I'll do it over here. I may have to delete a column. I never did it on this one like this, so this is a little bit new. Okay, so let's see here. Let's say divide by, and let's go over to this one, and we'll use a different color scheme for this. Oops. Okay. Well, oops, no. I hate using computers. Okay, so this first one, sum x times x. Now this is similar to this over here. So we sum up, but we do the multiplication first. So x times x is just taking the x's and multiplying by each other. So let me show you what I mean by that. So I'm going to take 5 times 5. Darn it. I'm going to get rid of a row here. Okay. column. I don't know. What am I doing? Okay, 5 times 5 equals 25. So we're just multiplying these two. And we're going to do the same thing for the rest of these. So 6 times 6.
So in this part, you're just multiplying the number of toasters produced by itself?
Yep. Yep. Yeah, so the x's are just the x's, so it's x times x. You could also write this as x squared. I've done it in the past, x squared, for some reason it caused, I think, more confusion. But yeah, it's just x squared, basically. So $25 plus 36 plus 64. I think it's 125, isn't it? Oops. Let's put the right numbers in. How about 25 plus 37 plus 64? Yep, 125. So that is our summation of x times x. Okay, so coming here, so this will be, I goof mine all up. We need to delete a column. I don't think it lets me delete a column. I know what to do. Sorry about the spacing here, guys. The next class through here will have it easy, but that doesn't help you guys. So let's see, x times x is what, 125? Minus, okay, over here we have the summation of x divided by n. So this is, okay, so summation of x we already did. So there is a summation of x. 19. And n is still 3. Darn it. Okay, so this is, let me, okay. So summation of x is just 19. And now we're ready to start chunking the numbers out here. Let's see, these will be, actually, this would be a big bracket. Okay, I'm going to leave that one the way it is. Oops. I'm going to do this one all together. So if you multiply 19 times 186 and then divide by 3, so multiply and then divide by 3, you should come out with some number. $1,178. Don't forget to divide by 3. There, that's all. Divided by 25 minus 19 times 19 divided by 3, and that is not going to come out to be a nice round number. $120.33. If you keep to the pennies, you'd probably be okay on this one. So this is 120 and 33 cents. Hey. Oh, okay. There we go. Okay, so this is that becomes. This is what this becomes. Okay, then $1,205 minus 178 equals 27. 125 minus $120.33. I did that wrong. $467. So V equals 27 divided by 467.
Wait, Professor, did you divide the 27 by 3?
No, I subtracted it. These two are subtracting, so 100.
It'd be 19 times 186 equals 1178.
Yeah,
Okay.
yeah, and then divide by 3. Yeah.
Okay, yeah, I got it.
Where's my I gotta insert my shapes here. And I might as well do the ones I'm going to do here too. Okay, so this came out to 5. I rounded off the nearest cent, so 5.78. And so that's our variable cost. And this is our this is the variable cost per unit, and this is our best estimate of the variable cost per unit. I write that in. Stop helping me. Hey. Oh, no, I goofed it up. So this is the best estimate of the variable cost per unit, given the information that we have, given these 3 data points. This is the best estimate. And this includes all of the data points. Unlike the high-low method, that would just take the highest and the lowest. This includes everything in between. Now, for this one, there's only 3 data points. It's not that big a deal. But if you had 30 data points, the high-low method would ignore 28 of them. So you want to, this is a better method. It's more work, obviously, but it's a better method. Any questions on that thing? And once you get kind of used to using these symbols, they're really not that bad. I mean, it's just a matter of getting used to doing it. When I was in graduate school, I remember reading an article that had all this, it was a research paper and had all these symbols and stuff. And when you started kind of chunking through it, you realize how easy it really was. And that the article I was reading was just about average grade in a class, but again, it has all these symbols and stuff. And at first, your eyes kind of glaze over a little bit. Then you start looking through it and you go, okay, this is just, the average class grade or whatever it was. It wasn't that big of a deal. Okay, so we get the variable cost per unit. And then we come down here to this formula. Now this formula is actually, if you look at that, this is just the average total cost. Sum up y, divide by n. That is just the average total cost, right? If you wanted to average these total costs, what would you do? You'd add them all up, sum the y, divide by 3, right? That would be the average. So total costs, add them up, divide by 3, you get the average. That's all this is saying. What's the average total cost? Over here, the V is the variable cost per unit. You'll notice that these are the units. So sum up the units. This is just the average number of units.
I have a quick question, Professor. Like when you said average, I was thinking it would be the total cost, the 186 instead of average. How can you differentiate between average, the symbol between average and sum?
Okay, no, okay.
Because I would have used the 186 instead of the average.
You are going to use 186, and here's let me show you what I mean by that. So let's see here. So sum of y was 186, like you said.
Right.
Now you are going to divide that though by what's the n?
3.
Right. So wait. The n is an n. Okay, no, it's not really. So 186 divided by 3, that will give you the average of it. Now this is the sum of it. This is just adding it up, like you just said. This is 186. But now when we divide by 3, we're getting the average of it.
Okay, I see what you're doing. I think you just went one step before I did. Okay, I got it.
Now the V is the variable cost per unit. This will be this.
Right.
And we're going to multiply that by sum of x. Now x are just the units. So sum of that is that. Sum of the x is 19. Might not need to put a space in there. Divided by 3. Yeah, so let me change it. Yeah, so these are really just getting the averages. This is if you look at it, this is the average total cost minus the average variable cost. It's just like our high-low method, actually. Total cost minus the variable cost. So this is variable and fixed. Let me put that in here. Let me see if that makes sense. So this is both variable and fixed. Oops. Hey. Subtract out the variable, and you'll be left with a fixed. This is total variable and fixed cost. Subtract out the variable, left with just the fixed is what we want. So this will be all right. So let's start chunking these numbers out. So this is 6, 3, 62. Minus, I'm going to do all these together. So 5.78 times 19 divided by 3. I guess I can do it over here so you can actually see what I'm doing. Okay, 5.78 times 19 divided by 3. 36.61. All right, so 36 of them, whatever that is. Oh, I lost my shapes. $25.39. And so this is the fixed, I should say total fixed. And this is also the best estimate of it. Total fixed, I don't know, make some color here. It's a little bit loud. There we go. We'll use that one. So total fixed cost. So, and this is our best estimate of the total fixed cost, 25,390. So the whole reason why we're doing this is that it's more accurate. You know, it's a better number because it doesn't ignore data points. We're doing it with 3. You know, we could do it with 30. It would just add more things to multiply. The idea is exactly the same. But yeah, so this is just using the total cost to come up with the variable and fixed cost. And one of the reasons why we do this is that it is the best estimate, and it's also not biased by, you know, if you were to look at the total cost, you might look at something and think that it's a variable cost when it really is a fixed cost. And for whatever reason, you know, you can come up with a wrong decision like that, which can make your could give you the wrong information, make the wrong decision based on it. Whereas this just says, okay, here's what, you know, statistically, here's what's variable and here's what's fixed. Question on that? All right, something this fun should be saved until next week. So I think we'll stop right here. You don't need to do anything else in this handout. You guys have the test is due. The chapter 3 test is due tomorrow night, midnight. So we'll just concentrate on that. All right, let's see here. Okay, so yeah, so we did what, pages 1, 2, and 4. You don't need to do anything else. Just get the chapter, if you haven't already. So I know some of you already got it in, but if you get the chapter 3 handout practice exam and that problem that we did together, 331, I think it was. Get those in and in the exam, obviously, and that, I think it's due tomorrow. Due on the 2nd. Yes, tomorrow. And that'll be it for tonight. Any questions on that? And we're gonna do. There's a couple more of those regression ones in there, and we may do something else. Even if we may do an Excel. I'm not sure. Well, we'll take I'll see about next week, but.
Professor, we're just gonna save this sheet till next week.
Yes.
Okay.
Yeah, don't do anything with the sheet. I'm not going to put a drop for it or an assignment for it. So just hold on to it. When we finish it, we'll turn it in.
Gotcha. All right. Have a good night.
Yeah. Okay. Good night.
Have a good one.
Right. Let's see here.
Good night.
Good night.